Hello everyone. Welcome back to the lecture series of trigonometry. This is important for ICSE 10th as well as CBSE 10th. We did 4 videos before on trigonometrical identities. Today it is our last video where we are going to cover some more sums so that you can have a good practice. My name is 𝐓𝐫𝐢𝐠𝐨𝐧𝐨𝐦𝐞 and you are watching 𝐓𝐫𝐢𝐠𝐴 classes. Let's start. The first question is sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta is equal to tan theta. So let us start with the left hand side. In the numerator we have sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta. From the numerator we can take sin theta common. So I'll take sin theta common. Inside bracket I get my 1 minus 2 sin square theta. From the denominator I can take cos theta common. Inside the bracket I get 2 cos square theta minus 1. Now I can see this sin theta upon cos theta will give me tan theta, which is there in the right hand side. That means somehow I need to cancel the part which is there inside the bracket. So if I can convert sin theta into cos theta or cos theta into sin theta, I may cancel the part which is inside the bracket. So let us write down tan theta for this part. For sin theta upon cos theta I am writing tan theta into, here I am writing 1 minus 2 sin square theta as it is. Down for cos square theta I am writing 1 minus sin square theta. See what did I do? I just wrote 1 minus sin square theta in place of cos square theta. So 2 whole into 1 minus sin square theta minus 1. We can put another bracket over here. So it is tan theta into 1 minus 2 sin square theta in the numerator as it is. Down will multiply this 2 into 1 2 minus 2 into sin square theta, that's 2 sin square theta, and this is minus 1. Let us put it inside a bracket. So we get tan theta 1 minus 2 sin square theta in the numerator. Denominator you can say this is 2 minus 1, which will give me 1 minus 2 sin square theta. So I am writing this. So this and this gets cancelled and we get tan theta, which is in the right hand side, proved. Let us start with the next sum. Sin A tan A upon 1 minus cos A is equal to sec A plus 1. So we'll take the left hand side. It is sin A tan A upon 1 minus cos A. Let us multiply by the conjugate of it. That is 1 plus cos A. To rationalize the denominator, we are multiplying by the conjugate of 1 minus cos A, which is 1 plus cos A, to the numerator and denominator. So at the denominator we have A minus B into A plus B, that's A square minus B square, and here I am getting sin A tan A into 1 plus cos A. So at the denominator I have 1 minus cos square A, 1 minus cos square A. This tan A can be written as sin A upon cos A, and we have 1 plus cos A. Now 1 minus cos square A can be written as sin square A. Here in the numerator also we are getting sin square A. So I am getting sin square A upon cos A into 1 plus cos A, and at the denominator I have 1 minus cos square A, that is sin square A. Now let us divide this sin square A upon cos A into 1 plus cos A. I wrote the numerator as it is. Now I will put a division sign, I will put a multiplication sign in place of division, and I will be writing sin square A, this sin square A in the reciprocated form, that is 1 upon sin square A. So this sin square A will get cancelled. Finally we get 1 plus cos square A upon cos A. Now let us split it up. We will write 1 upon cos A plus cos A upon cos A. So 1 upon cos A is sec A and cos A upon cos A is 1. Look at your right hand side, we got it. Proved. So the third question is under root 1 plus sin A upon 1 minus sin A is equal to sec A plus tan A. Let us take the left hand side. Under root 1 plus sin A upon 1 minus sin A. Let us rationalize it. Let us multiply by the conjugate, that's 1 plus sin A, to the numerator as well as the denominator. Everything will be going on inside the root. So in the numerator I can see I am getting 1 plus sin A into 1 plus sin A, which is my 1 plus sin A the whole square. Okay. At the denominator I have 1 minus sin A into 1 plus sin A, that's my A square minus B square, and this whole thing is inside the root. So in the numerator I am writing 1 plus sin A the whole square. Down I have 1 minus sin square A under root. Now again I am writing 1 plus sin A the whole square, and in place of 1 minus sin square A I will be writing cos square A, and that is under root. Now since both of them are in square form and it is under root here, so we can write 1 plus sin A at the numerator and cos A at the denominator. I just taken out the root. Now split it up, 1 upon cos A plus sin A upon cos A. Now 1 upon cos A is sec A, sin A upon cos A is tan A. Look at your right hand side, we got it. Right hand side, hence it is proved. Now the fourth sum looks like the third sum only. 1 minus cos A upon 1 plus cos A under root is equal to sin A upon 1 plus cos A. Now here I can see left hand side the denominator is 1 plus cos A, right hand side also the denominator is 1 plus cos A. So what we will do is we'll take this and we'll multiply the numerator with the conjugate of 1 minus cos A. That is, we'll rationalize the numerator now. Let us do this because I have to get the same thing at the denominator. Okay, so I'll not disturb the denominator. I'll just show you 1 plus cos A. So now what we'll do is we'll multiply the numerator by the conjugate of 1 minus cos A, which is 1 plus cos A. So we are multiplying the numerator and denominator by 1 plus cos A. So now we have in the numerator I have A square minus B square, and at the denominator I have A plus B the whole square. So this can be written as 1 minus cos square A, and down it is 1 plus cos A the whole square. 1 minus cos square A can be written as sin square A. Down we have 1 plus cos A the whole square. Now we'll take out both numerator and denominator out of the root sign. So it will be sin A upon 1 plus cos A. Look at your right hand side, we got it. Question number 5. 1 minus cos square A upon 1 plus sin A is equal to sin A. So let us take the left hand side and take the LCM. 1 minus cos square A upon 1 plus sin A. The LCM of the two term is 1 plus sin A. So in the numerator it will be 1 plus sin A minus cos square A. Now since at the right hand side we have only sin A, so we'll replace this cos square A by sin. So we'll write 1 plus sin A minus, in place of cos square A, I'll be writing 1 minus sin square A. Down I have 1 plus sin A. Now let us remove the bracket and see. 1 plus sin A, here it will be minus 1, and minus into minus is plus sin square A. Down I have 1 plus sin A. Here plus 1 and minus 1 will get cancelled. So in the numerator we have sin A plus sin square A. Down I have 1 plus sin A. Now in the numerator I can take sin A common. So if I take sin A common, inside bracket I get 1 plus sin A. Down I have 1 plus sin A. So this 1 plus sin A, 1 plus sin A will get cancelled and we get sin A, which is equal to the right hand side. Proved. Let us see the sixth sum. This is a very important sum. This has come in boards many a time and we have a trick to do this sum. So we'll take the left hand side, cot A plus cosec A minus 1 upon cot A minus cosec A plus 1. Remember, we'll not resolve it into sine cos nothing. We'll just write down in place of 1. We'll write this identity. We know 1 plus cot square A is equal to cosec square A. So cosec square A minus cot square A is equal to 1. So in place of 1, we are going to write this cosec square A minus cot square A at the numerator. Denominator we are going to keep as it is. So I am writing till cosec A as it is. Now in place of 1, I am just writing cosec square A minus cot square A. Down I will be writing it is as it is, the way it is. I will be writing the same thing in the denominator. Now see, this is my A square minus B square. So I will split it up in the form of A plus B into A minus B. Rest of the thing I will keep as it is. So it is cot A plus cosec A minus. Now this A square minus B square can be written as cosec A plus cot A, that is A plus B, into cosec A minus cot A, that is A minus B. At the denominator I have cot A minus cosec A plus 1. Now see, in the numerator we have got two terms. If I write it this way, this is one term and this is second term. Now from here I can take cot A plus cosec A common. So I will be taking cot A plus cosec A common. So from the first term we have only 1 minus from the second term we have cosec A minus cot A, which is inside a bracket. So we'll put another bracket over here. Down we have cot A minus cosec A plus 1. Now we'll remove the bracket from here. I'll have to rub the part above, otherwise I'll not be able to write it. So I'm rubbing this part. These two lines I'm rubbing and I'm doing it here. Now I'll just remove the bracket. I'll write this as it is. Cot A plus cosec A should be written as it is. Now here just remove the bracket. 1 minus cosec A, minus into minus plus cot A. So it will be 1 minus cosec A plus cot A. And down we have cot A minus cosec A plus 1. Now just see, this is cot A minus cosec A plus 1. Even this is cot A minus cosec A plus 1. So this and this will get cancelled. We get cot A plus cosec A. Now at the right hand side we have cos and sine. So we'll resolve this in the form of cos and sine. So cot A can be written as cos A upon sine A and cosec A can be written as 1 upon sine A. Now we'll take the LCM sine A. So it will be cos A plus 1. We already got the right hand side. Just write it the way it is written in the right hand side. 1 plus cos A upon sine A, which is equal to the right hand side. Proved. So question number 7 in front of us. 1 plus sine A upon cosec A minus cot A minus 1 minus sine A upon cosec A plus cot A is equal to 2 whole into 1 plus cot A. So let us take the left hand side. I am directly doing it. I will be taking the LCM here. So it is cosec A minus cot A whole into cosec A plus cot A is the LCM. In the numerator it will be 1 plus sine A into cosec A plus cot A. We have a minus sign in between, so minus. Now 1 minus sine A into cosec A minus cot A. Okay, now the numerator will multiply and the denominator we have A minus B into A plus B, that is A square minus B square. And at the denominator this is an identity, this is a third identity and we get 1 out of it. So we'll just multiply this 1 into cosec A, that is cosec A, sine into cosec A. So we'll write this way. Cot A into 1 is cot A. Cot A into sin A, that is sin A into cot A. Now this one. Minus 1 into cosec A is minus cosec A. Minus 1 into minus cot A is plus cot A. Minus into minus sin A into cosec A, that is plus sin A cosec A, and sin A into cot A, and this there will be a minus sin A cot A. So I multiplied the numerator completely. Now let us see, this is the 1, this has become 1, so we don't have to do anything here. This cosec A and minus cosec A will get cancelled. Sin A cosec A will give you 1. This is cot A and cot A, that will give you 2. Sin A, 2 cot A, sorry. Sin A cot A, and this is sin A cot A minus, so that will get cancelled. So there are 2 sin A cosec A and there are 2 cot A. So we are getting 2 sin A cosec A and plus 2 cot A. Now sin A into cosec A is 1 because we have cosec A is equal to 1 upon sin A. So if you get sin A this side, sin A into cosec A is 1. So this is 1. So we'll write 2 into 1 plus 2 cot A, which is your 2 plus 2 cot A. Take 2 common, so it will be 1 plus cot A. Now look at your right hand side. We got it. Proved. Well, so this was the last sum from trigonometrical identities. I tried to cover as many sums as possible. If you have any doubt, any more doubt, you can just write down in the comment section. I can come up with a solution of it. Thank you so much. Stay tuned.